is the mid-module review for Module 1. So the first question asks which term can be put in the blank to make the statement below true. So we're going to box this number on the right, and we see that it is an 80. So we're going to box out the same number in the 8 million. And once we box that out, we're going to replace it with a 1 and rewrite the numbers that are not in the box. And then we see that the number is 100,000. So the answer over here would be 80 hundred thousandths. A way to check it is to take 80 and multiply it by 100,000. We're going to ignore the zeros and just do 8 times 1, which is 8. And then we're going to count all the zeros. There's 6 of them, and we're going to put them back in. And we see that this number here matches the original number all the way over here. Question 2, it's asking in which number does the 6, so we're looking at the 6, represent a value 100 times. So 100 times is just like saying 10 times 10. So that we know we have to take 2 jumps in the place value system because there's 2 tens. So 100 times the 6 in here. So the 6 is in the tens place. And I have 10 times 10 or 2 zeros. Either way, I see it's 2 spots. So if I want to go 100 times greater, I'm going to jump 1 time and then the second time. So I need a 6 to show up right in this spot, which is the 1000 spot. And when I look down the 1000 spot in all my choices, there is a 6 in choice B. Question 3, there's a number below which says 145 and 36 hundredths. It says in a different number, the 5 represents a value which is 1/10. 1/10 tells me that I'm going to move to the right instead of to the left because I'm getting smaller. The 5 represents a value which is 1/10 the value of the 5 and the number above. So I'm going to find the 5 here, and it's in the ones place, and I'm going to go 1/10, which is 1 spot to the right, and I look at this place value, and that place value that they're asking me for then, the new one, would be the tenths. Question 4, we're going to write this number in exponential form. As a reminder, exponential is using exponents. So if we had 10 to the second power, the second power is the exponent. And that's the same thing as saying 10 times 10, because there is a 2 as an exponent, 2 tenths, or 10 times 10 is 100, 2 zeros. So we see that we can count the zeros. So in this case, I'm going to count up all these zeros. There is 6 of them, so I'm going to say that it's 10 to the 6th power. That's exponential form. Question 5, we have Joe. He is 49 inches tall. So just like in class, we're going to write the J, and we're going to say he's 49 inches, so we pull out our information. And then Peter is 5 feet 2 inches tall. So we're going to pull out that information. What I notice right away is that Peter's measurement is in 2 different units. It's in feet and inches, and Joe is just in inches. And then I notice the question says exactly how many inches, so my answer needs to be in inches. Taller is Peter than Joe. So we're going to convert Peter's measurement over here into inches. So we're going to start with our 5 feet. So we want to turn 5 feet into inches. And just like we learned, whenever we go from a measurement, if we're going from a bigger measurement to a smaller measurement, we are going to multiply. Big to small, we multiply. So we have 5, and there are 12 inches in every foot, so we end up with 60 inches. But we can't forget that there's also these 2 inches in Peter's measurement. So So then we have to do 60 plus 2, and Peter is 62 inches tall. And now the question asked us, how many inches taller is Peter than Joe? So we need to subtract the fact that Peter is 62 inches minus Joe is 49 inches. We have to borrow, and so there is a 13-inch difference. Question 6. The value of the digit in the thousands place in this number, 653,841. So this is the digit in the thousands place. Is 1/10 the value? 1/10 the value of the digit in the 10,000s place. In which number? So this one is 1/10 the value. So we want to find that digit in the 10,000s place. And if we look in the 10,000s place, we see the answer is B. Question 7 says, what's the value of 2,672 10,000ths rounded to the nearest tenth? So we're going to go back to our rules. So we want the tenth spot. It's right here. So we underline, we box the digit to the right. The 6 tells us it's big, it's a bully, it's going to push the 2 up to a 3. Everything to the left stays the same. And because we're on the decimal side, everything to the right, poof, disappears. And that's our number rounded to the nearest tenth. Question 8, the operation symbol and the exponent are missing. So this is our exponent up here, and this is where our operation goes. Operation is saying either addition, subtraction, multiplication, or division. So it says which operation and exponent go in the box to make the equation true. So when we look at this, we start with 6,430 and we end up with a larger number, 643,000. So since the number is getting bigger, we know that we need to multiply. So I can eliminate both that are division. So we know we're going to multiply. And we look at our number, we have 6,430, and here we have 2 extra zeros after, so we had to jump 2 spots. So because we jumped 2 spots, we know that our exponent has to be a 2, so the answer is A. Question 9. In 2005, the population of Sullivan County was 1,375,823. We now want to know the value, not the place, the value of the 8. Well, the value of the 8, it is in the hundredths spot, so it is worth 800. Question 10. Joanne learned the population of her town is 8,472. She wants to round that to the nearest 100. So we're going to rewrite the number so it's a little bigger. We want to round that to the nearest 100. The 4 is in the hundredths place, so we underline it. We box the number to the right. The 7 is big and strong like a bully, so he pushes the 4 up to a 5. Everything to the left stays the same, and because there's no decimal, everything to the right becomes a 0. Question 11. The table below shows the population of 4 different states in the month of May. What's the value of the digit 9 in the smallest population? So first I have to compare them and to see which is the smallest population. This is the smallest population. And now I have to find the value of the digit 9. So in this one I see the 9 is right here in the tens place. So its value is 90. Question 12. The highest point of Blue Mountain in New York is 3,975 feet. They want us to round that to the nearest 1,000, so I'm going to rewrite it. I'm going to find the digit that's in the thousands place. I'm going to underline it, box the number to the right. The 9 tells me to bump the 3 up to a 4. Everything to the right becomes 0 because there's no decimal. Question 13. The number of people who visited Great Adventure was 9,050,937. They just want the value of the 5. So I look over here. The 5 is in the 10,000s place, so its value is 50,000. What's true about rounding decimals? We want to make sure what's true, what's correct. So all of these questions seem to talk about rounding to the 100th. So I'm going to take each one and round it and see what answer I get. So that 6 bumps the 6 up to a 7. Everything to the left stays the same, and because it's on the decimal side, everything on the right disappears. Then we're going to round this one to the nearest 100th. 4 is weak, so it leaves the 7 alone. I'm going to solve each one, and then I will look at the answers to see what matches. So this is the 100th. The 7 moves the 1 up to a 2. Everything to the left stays the same, and we drop everything to the right. And this last one, the 5 bumps the 2 up to a 3. Everything to the left stays the same. So now I'm going to go through. This was 4 7/100ths. Oh, that answer seems to be there, so that would be good. But we're going to check all our answers to make sure they're correct. This is 4 7/100ths, so it's supposed to be 4 800ths, so that doesn't work. This says 4 1200ths, and it should be 4 1000ths, so that doesn't work. This is 4 300ths, and it says 4 200ths, so that doesn't work. So our final answer is A. Question 15. We're now doing conversions. So to see which one works, we're actually going to convert them all. So if I start with 6 meters, I want to see what I'm going to get to kilometers and see if it matches. And as we learned in class, we always do King Henry doesn't usually drink chocolate milk. So now we're going to do our conversions. We're going from meters to kilometers, which means that we're jumping to the left. And we jump 1, 2, 3 spots. So we start with our decimal, it's right here. So we're going to jump 1, 2, 3 spots. There's a decimal right there, and we're going to fill in zeros. So we have this answer right here. We have 6 thousandths kilometers. This does not work. It doesn't match. We have another question that has meters and kilometers, and we can see that that also doesn't match. So we're not using that one. So now we can try another one, and we can go from 6/10 centimeters, and we want to see how many millimeters that is. That's this one right here. So when we go from centimeters, we go from the C, and we move to the millimeters, so we're moving to the right 1 spot, so we know we're moving to the right. And when we move to the right 1 spot, we have this as an answer. You can also write just that as an answer. Either way would work. So 6 millimeters equals 6/10 centimeters. So let's try another one. We can try C, where we have 6 millimeters. How many centimeters does that equal? So we're going from millimeters, and we go to the left, and we want to see where we end up. So if I have 6 millimeters, and we go to the left 1 spot, we end up with 6/10 centimeters. So if we look through this, we see so far that this didn't work as well, and this didn't work as well. So now we're going to go back and see. We thought this one didn't work, so let's check it. If we have 6,000 meters, how many kilometers do we have? We're going to use our chart again. We're going from meters to kilometers. We're going left. So we're going to go 1, 2, 3. Decimals here, 1, 2, 3. Oh, our answer before was wrong. So we have this, which tells us that's the same thing as if I dropped off the zeros, and 6,000 meters equals 6 kilometers. So this is our answer down here. So we should check each one individually rather than making an assumption. Question 16. In 1999, approximately 900,000 people visited New York City's aquarium. How many thousands are in 900,000? So if I have 900,000 and I want to see how many thousands are in it, we're going to work backwards. We're going to take our thousands, and we know we have to multiply it by 9, because 9 times 1 would give me 9. And then, if we multiplied by 1,000, that would be 1, 2, 3 zeros. So let's get rid of 1, 2, 3 zeros. How many zeros are left? 2. So there are how many thousands? It looks like 1,000 times 900. Does that give me how many thousands there are? Yes, because if I multiply 900 thousands, that's how I would get to 900 thousands. So my answer is 900. There are 900 thousands. Question 17. How many times greater is the value of the digit 3? So here it is. Then the value of the digit 3 in here. How many times greater is the 3 in here? And then the 3 in here. So here, the 3 is actually in a smaller spot. It's in the thousands spot. And then over here, the 3 is in the 100,000 spot. So because this is smaller, it's 2 spots smaller. That's the same as saying 1/100th. Because we're looking at the first number first. And this number is the smaller number. And since it's a smaller number, it's 1/100th of the bigger number. Compare the value of the 4 in this number, which is the tenths, to the value of the 4 in this number. That decimal at the end is actually a period, is hundredths. So the value of the 4 in the first number is the tenths compared to the value of the 4. This one is 10 times greater because this is in a larger place value, 1 spot over. 10 times greater because it is 1 place value larger. Next, question 19. Chris had a piece of wire that's 5 feet 9 inches. What's the length in just inches? And I must show my work. So we want to turn 5 feet into inches. And just like we had learned in class, we want to make sure this unit is bigger, this unit is smaller. So when we go from big to small, we multiply. That's what we learned. Big to small, multiply all. So we need to know how many inches are in a foot. So we should know that 12 inches equals 1 foot. So then we know that we should multiply 5 times 12, and that gives us 60. But we're not done, and we have to be careful because right here there was 5 feet, but there's also 9 inches. So we have to finish doing our work by saying 60 plus the 9, and that's 69 inches. That's how big that piece of wire is. Next, we have some string. Based on the table above, put the string lengths in order from least to greatest and use an inequality symbol. Don't forget this, and don't forget it's least to greatest. Now, luckily, it says to show your work as a reminder. So when we show our work, we always have to stack, and that's one of the biggest things that we sometimes forget. So I'm going to stack on the side over here. We'll use this side. I'm going to stack them over here. Stack means I'm keeping them in order right now, just lining up those decimals so I line up my place value. So now anything that's empty, I have to fill in with a 0. So now I want least first. So I look through these and there's a 1 and a 1. So I look through the next number and they both have a 0. They both have a 5, but the bottom one has a 3. So when I see that and I look through that, I'll lower this a little so we have more space. And over here I'm going to write 1 and 53 thousandths. And then the next number that also has a 1 was way at the top, and that was 1 and 55 hundredths. Sorry, thousandths. So now we're going to look at the other numbers. They all have a 2, 2, 2, 2. They all have a 3, but the bottom one has a 4. And then we keep going, and we're putting them in order. So now they're all in order. Many of us would stop right there, but we have to make sure we do this inequality symbol right here. So it's in order from least to greatest, so we have to say that this is smaller than this, which is smaller than this, which is smaller than this, which is smaller than this. And that gives us our order of least to greatest. Question 21, write the expanded form in standard form. So standard form is a regular way we write a number. So we see we have a 10 thousands, a thousands, a hundred, a 10, a 1, a tenth, and a hundredth. So when we write it, we have 58,295 and 42 hundredths. Make sure our decimals look like decimals and our commas look like commas. And now it says to write it in word form, which is basically what I just read to you, but I will write it now. So it's 58, and there's a comma, so it's thousands. 295 and then we look here after the decimal. The decimal tells me to write and then I look at my box and it says 42. And what place value does it end in? It ends in the hundredths. And I have to make sure when I say it ends in the hundredths that it's THS. And now it says to write a number that is 1/10 that number. So I'm going to go back up here for a minute. And we have this number right here. 1/10 that number means that everything has to shift to a smaller place value. So in order to shift to a smaller place value, we have to move everything over one spot. So since it's 58,000, we're going to go down here and we're going to just write 5,000. We're going to shift over the 8, the 2, the 9, 5, the 4, and the 2. We shifted everything over one spot because 1/10 means we want it to be smaller. So shifted everything to the right one spot. And that is our mid-module review.